I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Researchers in the UK may soon be taking us closer to finding Earth-like planets outside of our solar system with a breakthrough in spectral shaping. A team at Heriot-Watt University has developed a spectral shaper that can, with higher precision than ever before, shape the spectrum of light across the visible and near-infrared wavelengths emitted by a laser frequency comb, essentially a ruler that measures light. Inspired by the astronomical spectrographs on large telescopes, the new technology makes lines on a frequency comb more uniform. This allows a spectrograph, commonly used in the search for planets, to better detect tiny stellar movements. Such subtle movement is typically lost amid surrounding noise. In using their spectral shaping approach with a lab-based astronomical spectrograph and spatial light modulator, the team has been able to control 10,000 individual lines of light across 580 to 950 nanometer wavelengths and a bandwidth resolution ratio of more than 20,000, while also allowing the spectrum to be shaped. The team plans to test its spectrum shaper in space observations using the Southern African Large Telescope. It's almost that time of year again when SPIE shines a spotlight on the most innovative new photonics products via its annual Prism Awards. The 2026 finalists were recently announced in each of 8 categories, recognizing companies that are bringing transformative products to market. Among the finalists are Dose Optics in the biophotonics imaging category for its beam sight, an imaging system designed for real-time visualization of radiation dose delivery during radiotherapy. In the quantum technology category, Toptica Photonics is among the finalists for its Topticlock, an optical quantum clock that uses a laser-cooled ytterbium ion. MetaLens is a finalist in the Cameras and Imaging Systems category for its Polar ID technology, a polarization sensor for smartphones that offers ultra-secure facial authentication in a condensed footprint. Winners in all categories will be announced at the 2026 Prism Awards Gala during Photonics West on January 21st. Control of nanophotonic devices could enable more than simply being a source of single photons, to someday enable larger quantum emitter systems on a single chip. Researchers from the Silicon Quantum Technology Lab at Simon Fraser University and quantum company Photonic Inc. in Canada have developed a diode nanocavity that allows dual optical and electrical control of specifically silicon color center qubits, also called T-centers. The team's work builds on their development several years ago of a silicon nanophotonic device that can control single T-centers optically with lasers. Now, adding electrical control to the process could reveal new capabilities, including in nanophotonics and photonic integrated circuits. There are now efforts to develop electrically injected single photon sources that rely on the combination of silicon photonics and other materials, something the team says could simplify integration. Combining dual electrical and optical control with nanophotonic devices could also boost quantum applications, specifically scaling up to larger systems of quantum emitters on a single chip. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Check out our Following the Photons podcast, too, for some cool interviews and news impacting the industry. Until next time.